A very good morning to all. Koregaon MPS Municipal Secondary School is BMC Education Department. So today we are going to continue with our topic of chemical reactions and equations. So let's start with our topic. So today we are going to see about the factors affecting the rate of chemical reactions. So here there are different factors which affect the rate of reaction. Likewise, some of the factors are due to the nature of the reactants. How will be the reactants? If reactant is highly reactive, then the reaction will be fast. If it is less reactive, then reaction will be slow. Then comes the size of particles of reactants. How will be the size of particle? If bigger size is there, what will be its effect towards the rate of reaction? If smaller size is there, what will be its effect towards the rate of chemical reaction? Then comes the concentration of the reactants. Concentration of the reactant means if the number of molecule is more, that is if the concentration of the solution is more. Okay, so then what will be the your rate of reaction, whether it will increase or it will decrease? Then comes the temperature. Now, whether the temperature it decreases the rate of reaction, that means if the high whether the high temperature decreases the rate of reaction or it increases the rate of reaction. Then comes the catalyst. So the substances in which the presence its presence increases the rate of reaction, or in some cases it decreases the rate of reaction, but it does not make any changes in itself. It is a catalyst. So all these things we are going to see in the factors affecting the rate of chemical reaction. So one by one we will look after each and every topic of this factors affecting the rate of chemical reaction. So let's start with the first point, that is the nature of the reactant. Now, nature of the reactant. What should be the nature of the reactant while performing any reaction? Which kind of reactant you should use? Okay, so the rate of reaction depends on the nature of the participating substances. So whatever, whether that reaction will took quickly or it will take some time. So it depends upon the nature of the reactant. How is the reactant? Okay, so whether it is highly reactive or less reactive. If it is highly reactive, then the reaction will appear quickly. But if it is a less reactive reactant, then what will happen? The reaction will not take place quickly because it will take some time, because its reactivity is less. So then the reaction that appears similar may have different rates under the same condition. Okay, now suppose two reactions, you are dealing with the two reactions. Now it seems to be it is very similar with each other and both will take the same time, but this does not happen. Even if you are giving all the same condition and whatever the condition which are required to take part in that particular reaction, but it depends upon the identity of the reactant, whether that reactant is highly reactive or it is less reactive. One of the example is between the aluminium and zinc. Okay, now suppose the metal aluminium and zinc, they both are reacted with dilute hydrochloric acid. Okay, so what happens there? Now when these two elements, or when these two metals, they react with dilute hydrochloric acid, H2 gas is liberated and water soluble salts of these metals are formed. But the reaction of aluminium metal, it takes place faster as compared to that of the zinc metal. Now why this rate of reaction is more in aluminium than that in zinc? Because the nature of the metal is responsible for this particular difference in the rate of reaction. That means aluminium is more reactive than that of zinc. That's why the rate of reaction is more in aluminium. Now see, both the metals, both the aluminium and zinc, both are reacted with dilute hydrochloric acid and both are giving the near about same products only. But the rate of reaction is much higher in aluminium than that in zinc. That means the reaction in aluminium is taking place faster as compared to that of zinc. Why? Because aluminium is highly reactive than that of zinc. So here you can say that the rate of reaction increases as the reactivity increases of that particular reactant. So here one of the example is also given, that when the small pieces of metal ion and sodium, they are exposed to air. Okay, so metal ion and sodium, you just kept it over one table and it is exposed to air. So in that place, what happened? The sodium reacts completely with air overnight. So overnight you keep those metals as it is over the table, and when you will come in the morning, you will see that all the sodium, whatever the sodium was there, it all reacted completely overnight. Whereas the iron is barely affected. Iron was not affected that much. Okay, so why this happens? Because of the rate of reaction of sodium, which is higher than that of the iron. So one of the example is the active metal calcium and sodium. Both they are reacted with water to form hydrogen gas and a base. Then what will happen? Calcium react at a moderate rate, whereas the sodium will react so rapidly that the reaction is almost explosive. Okay, so in both these examples, one of the example was metal ion and sodium. Both are individually kept over a table for overnight, and when you came in the morning and you will look after that table, that you will see that all the sodium have been reacted with the air, whereas the iron was barely affected. That means the rate of reaction of sodium was more in this case, okay, as than that as compared to iron. Iron was having a very less reactivity. Then in the second example, active metal calcium and sodium, they both are reacted with water. Okay, calcium is reacted with water and sodium was also reacted with water. Okay, then what will happen after reaction with water? When calcium reacts with water, hydrogen gas and base, these products are formed. But in calcium, the rate was at moderate rate. It was slow. But when you reacted sodium with water, it will also give the same product as that of the calcium, that hydrogen gas and base. But in this case, the rate was so rapid and it was explosive. That means sodium is highly reactive than calcium. It is highly reactive than iron too. Both the examples, I hope you have understood. Then you can see this is a sodium metal. Okay, so when sodium metal is likewise solid and sodium metal is kept in kerosene, it is not exposed to air, because if you will expose it to the air, it will react so fast that all the sodium metal will be reacted. So it is kept in a kerosene oil. Then you can see the solid form of sodium metal, little bit finely divided sodium metal. So these two are the pictures of sodium metal. Then comes the size of particles. Now size of particles also affects the rate of reaction. Now, as you might have seen that suppose in a lab, if you reacted one powdered form compound and if you reacted one liquid form compound and one solid, okay, in three of these cases, which one will react more? Obviously the compound which is in powdered form, it will react more. Why? Because the powdered form compound is having loosely bond connected with the atoms and molecules which are present in that particular compound, whereas it is little bit more stronger in liquid and it is highly stronger in solid. So that's why the rate of reaction in powdered form is more than that in a liquid than that in a solid. Okay, so in this case you can see that if you took an example of gases, liquids and solids, if you consider these three mediums, so in that case the rate of reaction in gases medium will be more than that in liquid, and that in liquid it will be more than that in a solid. So you can say that the rate of reaction, it increases from gaseous state to the solid state. Sorry, it decreases, not increases, it decreases. Okay, that means the gaseous medium will be having a higher rate of reaction than that in a liquid, and liquid state will have the higher rate of reaction than that in a solid. So here you can see the rate of reaction is generally slower in liquid when it is compared to gaseous. Now suppose one gaseous state compound is taken and in another side liquid state compound is taken. So in both the cases what will happen? When you are reacting those two things with particular solution, then the reaction in the gaseous state will be much higher, than that in a liquid state. Why? Because gaseous state is having all the bonds loosely connected and they are free to move, and that's why they react very fast as compared to the liquid. Then in the second case, if you took the example of a liquid and a solid, then obviously liquid will have the more rate of reaction. Why? Because the bonds in a liquid are much less strong than that in a solid. Solids are having highly strong bonds. They are connected with each other with a strong bond, and it is difficult to break. It takes some time to break. Okay, but whereas in liquid, it is easily breakable. So the solution which will react in a liquid medium, it will react it much more faster than that in a solid state. So the rate of reaction is generally slower in liquid when it is compared to gaseous, and it is slower in solids when it is compared to liquid. So the size of the reactant also matters a lot. So the smaller the size of the reactant, the faster will be the rate of reaction. Now always remember, when the size is smaller, the surface area increases. Okay, the absorption capacity of that particular compound also increases. And because of that, what happens? Collision increases. And as the collision will increase, okay, the atoms and the molecules which are present, they start colliding with each other, and faster will be the rate of reaction. So, except for the substances in the gaseous state or in solution, reactions occur at the boundary or interface between the two phases. Hence, the rate of reaction between two phases depends to a great extent on the surface contact between them. So, finally divided solid has more surface area available for reaction than does one large piece of same substance. Okay, as I already told you, finely divided solid, that means a powdered form compound or a powdered form any of the substances, when it is reacted with any other compound, then the rate of reaction is higher for the finely divided substances. Why? Because its surface area is more. Okay, it will be having a higher surface area, so the rate of reaction also increases because of it. So a liquid will react more rapidly with a finely divided solid. Obviously, a liquid, when it is added in a finely divided solid powder, then what will happen? It will react more quickly because that finely divided powder will absorb that liquid faster, and it will, whatever the atoms are present inside, they will collide faster. And because of this, what will happen? The rate of reaction will be faster. So for example, large pieces of iron react slowly with acid. Okay, so the large pieces, what if the large pieces of iron are put in a beaker, and over it I pour some of the acid, then its reaction will be slower, whereas the finely divided iron, they react much more rapidly. But if suppose small pieces of iron and finely divided pieces of iron, if it is placed in a beaker and I put some acid over it, the reaction will be more rapid. Why? Because in that finely divided iron, the surface area will be more, and hence as the surface area will be more, then the collision will be more, and if collision will be more, so rapid will be the rate of reaction. So the large pieces of wood smolder, then smaller pieces burns rapidly. Okay, and sawdust, they burns explosively. You might have experimented that if suppose a wood block, you want to burn it, it will take time. But whereas if a small pieces, very thin pieces of wood, if you start burning it, then what will happen? It just explodes. Small pieces of wood means you can call it as a sawdust. You might have seen that in a chalk box, what chalks were placed above the sawdust which is present in a chalk box. So there, in that cases, so sawdust, it burns explosively. Okay, it will burn explosively than that with as compared with the wood block. Then the difference in the inherent structure of reactant can lead to differences in the reaction rates. Okay, so molecules joined by stronger bonds will have lower reaction rates. Okay, now solids are there. As you know that solids, they form a kind of geometrical structures. So these geometrical structures means all the elements and all the atoms, they are attached with each other with a stronger bond between them. So these bonds are difficult to break in a solid, whereas it is weakened in a liquid. So that's why these bonds can be broken in a liquid. In a solid also we can break it, it is not impossible, but it will take some time as compared to that of a liquid and as compared to that of a powdered form or a gaseous state. So here molecules joined by stronger bonds will have a lower reaction rates than will molecules joined by the weaker bonds. So due to the increased amount of energy required to break the stronger bonds. Then comes, by decreasing the particle size of the reactant, we are increasing its surface area. So always remember, as the size of the particle decreases, okay, so the surface area will increase. Okay, so the greater surface area means there is a chance, higher chance of collision, and this higher chance of collision resulted in the faster rate of reaction. So the smaller the particle, the faster will be the rate of reaction. Always remember, less is the size, more will be the surface area. Less is the size means if it is a powdered form compound, then the surface area will be more. Okay, and there will be high rate of collision. All the atoms and molecules will start colliding with each other in a high frequency, and what will happen, faster will be the rate of reaction and we will get the product quickly. Then when the concentration of the reactants are raised, the reaction proceeds more quickly. Same case here happens, that when the concentration of reactant is more, okay, that means concentration of reactant means when the number of molecules which are present in that particular solution is more, obviously the rate of reaction will be more. And if the rate of reaction will be more, that means there is a higher chances of collision, and hence we will get the product as fast as possible. Then for gases, increased pressure has the same effect as increase in concentration. Now higher will be the pressure in the gases means it is equivalent to the higher concentration of the solution. Okay, so when the solids and liquids, they react, so increasing the surface area of the solid will increase the reaction rate. If solid is there, if its surface area is higher, that means if it is powdered form solid, then its reaction rate will be higher, obviously. But if its particle size is more, then its reaction rate will be lower. Why? Because higher particle sizes, they are having the high bond strength and it is difficult to break them easily. So it takes some time to break that. So it is not easy to break the bond which are highly solid form structures or big size particles, you can say. Then a decrease in the particle size causes an increase in the solid's total surface area. Okay, so then comes concentration of the reactant. Okay, now here in this case, concentration of the reactant means, as I already told you, concentration means if suppose two solutions are taken. Okay, now suppose dilute HCl is there and concentrated HCl. Now, what do you mean by this concentrated HCl and dilute HCl? HCl means hydrochloric acid. So, in this case, concentrated HCl means the number of molecules in concentrated HCl is more. Whereas in dilute HCl, the number of molecules of HCl is less. Okay. So, here in this case, the solution containing higher number of molecules, they will react faster, okay, as compared to the solution containing lower number of molecules. So as the number of molecules are more, the reaction rate will be fast. The collision between the atoms in the molecule will be more, and hence we will get the product easily and quickly. Thus the rate of reaction increases with the increase in the concentration of the reactants. So the rates of many reactions depends on the concentration of the reactant. So the rates usually increase when the concentration of one or more of the reactant increases. Okay, so whenever suppose two reactants are there And if we increases the concentration of one reactant, in that case also the rate of reaction increases. So if you want to speed up your reaction, you have to increase the concentration of that particular reactant. So for example, calcium carbonate, okay, it deteriorates as a result of its reaction with the polluted sulfur dioxide. So the rate of this reaction depends on the amount of sulfur dioxide in air. Now what happened? This sulfur dioxide, it combines with water vapor which is present in the atmosphere, in the air, to produce sulfurous acid. You can see the reaction here, SO2 plus H2O. Okay, so this sulfur dioxide, it combines with whatever the water molecules are present in the atmosphere, it combines with it. And after combination, what it will give? It will give sulfurous acid. Okay, then SO2 and water. Then what happens here? After that, this sulfurous acid is formed in the following reaction which is given below. Now this sulfurous acid, okay, what it will do? It will react with calcium carbonate. And as it will react with calcium carbonate, then what we will get? We will get calcium sulfide. Okay, and carbon dioxide and water as a side product. But the main is the calcium sulfide we will get. So what happens here? Due to increase in the concentration of the reactant, the rate of reaction it increases. Okay, so concentration, it depends upon the number of molecules which are present in the reactant. If the number of molecules are more, the concentration is more. And if concentration is more, then higher will be the collision. If higher will be the collision, then higher will be the reactivity. And if higher will be the reactivity, the rate of reaction will be high. Then comes the temperature of the reaction. Now temperature of the reaction means, now chemical reactions typically occur faster at high temperature. Okay, now you might have seen that in your home, when we cook the food, okay, whenever we want that it should be cooked faster, and at that time we increase the speed of that particular burner. Okay, so that means we are increasing its reaction. If you are increasing the temperature, the rate of reaction will increase. So here food can spoil quickly when left on the kitchen counter. You might have seen, suppose in the morning the food has been prepared and you just kept it for the whole day as it is over the kitchen floor, then what will happen? Till night it will deteriorate, it will smells pungently. Okay, why? Because this temperature, whatever temperature was there around that particular food, then because of that temperature, the chemical reaction, it increases because of the temperature present. So what we do, whenever if food is prepared, we kept it in the refrigerator, so that what will happen in the refrigerator, it slows down the process of chemical reaction and it keeps the food as it is fresh for days. So that's why whatever food are bought and whatever things are bought, whatever we made, so if we want to store it, we keep it in the refrigerator so that the rate of chemical reaction will decrease. So here temperature is having a very vital role to increase the rate of reaction. So if the temperature increases, the chemical reaction also increases. So one of the example of the food is it's a very good example. So if you want to cook food fast, then you increase the burner. Then if you keep that food outside for the whole day, then obviously because of the chemical reaction, it will not the food will not be good till night. Then suppose if you keep that food in the refrigerator, as because of the lower temperature, the rate of reaction will decrease. Okay, because of the decreased rate of reaction, what will happen? The food will not get spoiled, so it can remain fresh for days. So we use a burner or a hot plate in the laboratory to increase the speed of the reaction that proceeds slowly at ordinary temperature. Now in the laboratory, in the chemical laboratory, what happens if we want to increase the speed of the reaction? Suppose two solutions are there and want the reaction very fast. So what I will do? I will combine those two solution in a test tube, and I will try and I will keep that test tube over the burner, so that because of the temperature, what will happen, whatever the bonds are present between the compound, they will break faster and they will react faster with the compound which is with which it is reacted. And after that, what will happen, we will get the product faster. Why? Because we are giving the temperature, and because of the temperature the rate of reaction becomes higher and we will get the product quickly. So in many cases, an increase in temperature of only 10 degrees centigrade will approximately double the rate of reaction in a homogeneous system. Homogeneous means suppose liquid is reacted. In that case, it will double the rate of reaction. So here temperature also plays a very important role to increase the rate of reaction. So higher will be the temperature, higher will be the rate of reaction. That means higher will be the, because of the temperature, the bonds which are present between the compounds, that will break faster and it will react quickly with the reactant which is present with that particular reactant. And because of it, higher will be the collision and the reaction which will be formed will be higher and the product we will get quickly. So that's why the rate of reaction will be increased. Then comes the catalyst. Now, what do you mean by the catalyst? So, catalyst is that substance that increases the rate of reaction, okay, but it itself does not undergo any change, okay. So, it will make the change in the reaction, either it will increase the reaction or it will decrease the reaction, okay. Most of the cases we are using the catalyst to increase the rate of reaction so that the reaction get fast and we get the our product fast, so that the reaction it appears quickly. So that's why these catalysts, these are the substances which increases the rate of reaction by lowering the activation energy needed for the reaction to occur. So here a catalyst is not destroyed or changed during a reaction, so it can be used again and again. We can use it again and again because it itself does not undergoing any change. It's itself not destroying also itself, nor it is changing itself. So we can use those catalysts again and again. So for example, at ordinary conditions, H2 and O2 do not combine. Okay, suppose you want a reaction between the H2 and O2. So if you simply you are combining both these elements, it will not both these compounds, it will not react. So what will happen, we have to speedify it and we have to make the reaction between them. So what we will do, we will add one catalyst. So they combine in presence of small quantity of platinum which acts as a catalyst and the reaction then appears rapidly. So here, if you want to combine H2 and O2, you have to add one catalyst, that is platinum, so that the reaction will occur. So here many of the reactions are there which does not happen itself. So it requires some of the catalyst, so that what will happen, because of the catalyst the rate of reaction will appear. And if you add the catalyst, obviously it increases the rate of reaction. Now, catalysts are of two types. It is a positive catalyst or it may be a negative catalyst. Now here, positive catalysis means what? A catalyst which increases the rate of chemical reaction is called as the positive catalyst. And this phenomena is known as the positive catalysis. Okay, so here you can see examples. When potassium chlorate, okay, potassium chlorate is there, two compounds of potassium chlorates, when we reacted them with each other, then what will happen, or a potassium chlorate is there, and if you want to break it down, okay, so if you want to break this down, we have to add one catalyst so that it can break down. So KClO3 we are breaking down into KCl and thrice O2. Okay, that means we are breaking down into potassium chloride and oxygen. So while it will not break down itself, so we have to add some of the catalyst. Okay, so MnO2 is being added. That is the manganese oxide is being added so that this breakdown can appear of KClO3, that is potassium chloride. So as we are adding this MnO2, that is the manganese oxide, so here it acts as a positive catalyst because it increases the rate of reaction, plus it is it is pertaining the rate, it is giving us the product from this particular reactant. Then after that comes the H2O2. Now H2O2 means hydrogen peroxide. Okay, H2O means water molecule, and whenever it comes H2O2, then it is hydrogen peroxide. So when hydrogen peroxide is there, when we want to break it down into water and oxygen, so what we will do, we will add some catalyst because it itself does not undergo breakdown. So same as that with the case of the KClO3, H2O2 also needs some catalyst so that it will break down into water and oxygen. So we are adding their platinum so that it acts as a catalyst and it increases the rate of chemical reaction also. It increases its rate also, and plus it is helping to break down the hydrogen peroxide into water and oxygen. Then comes the negative catalysis. Now here the catalyst which decreases the rate of reaction is known as the negative catalyst, and the phenomena is called as the negative catalysis. So there are few catalysts which increases the rate of reaction. There are few catalysts which decreases the rate of reaction. So these these are few of the examples of positive and negative catalysts. So for the negative catalyst, when H2O2, we want to break down the H2O2, okay, into water molecule and oxygen, but we want to decrease the rate of reaction. We don't want it fast. Okay, we want to slow down the reaction. So for that case, we are adding a negative catalyst. One of them is acetanilide. Okay, so if we want to break down the H2O2, that is the hydrogen peroxide, in presence of catalyst, but we want to decrease the rate of reaction. Okay, now here you can see that the H2O2 example in positive catalyst and in negative catalyst. In both the cases, the product we are getting same. Okay, because we are only breaking it down. H2O2 is only broken down into water and oxygen. In both the cases, products are same, but we are using different catalyst. Why? One is for increasing the rate of reaction and another is for decreasing the rate of reaction. Here in the negative catalyst, we are decreasing the rate of reaction. That's why we are adding acetanilide as a catalyst. Whereas in example in the positive catalyst, we are increasing the rate of reaction. For that increasing the rate of reaction, we are adding platinum there. Then one of the example of negative catalyst is knocking off the petrol by tetraethyl lead. It is also one of the example of negative catalyst. So positive catalyst means which increases the rate of chemical reaction. Negative catalyst means which decreases the rate of reaction. Then comes the corrosion. So before that, in short, we will revise these factors affecting the rate of chemical reaction. First of all was the nature of the reactant. Now, nature of reactant means if the reactivity is higher, the rate of reaction will be higher. If the reactivity is lower, the rate of reaction will be also lower. So it depends upon the reactivity of the reactant. Okay, whether it is highly reactive, then only the rate of reaction will be more. If it is less reactive, the rate of reaction will be less. Okay, then comes the size of the particle. Now here in this case, the size of particle, if it is lower, then its surface area will be more. Okay, if the size of the particle decreases, surface area increases. And as the surface area increases, collision will also increase. And if collision will also increase, then faster will be the rate of reaction. Okay, then we have seen that in solid forms, the bonds are more stronger. So in that case, what will happen if the bonds are stronger? So it will take more time, okay, to get the product. So the rate of reaction will be higher in solids than in liquids, and then after that in gaseous state. That means you can say that the gaseous form or the powdered and the powdered form both will be having the high rate of reaction. After that comes liquid, and after that solid. Then we have seen that how the decrease in size, it will increases the surface area. Then concentration of the reactants. Now here in this case, you know that as the concentration increases, okay, the number of molecule in it increases. So as the number of molecule increases, so reaction will be quick, okay, and it will take less energy to proceed. So that's why the rate of reaction increases as the concentration increases. Then comes the temperature. So in simple way, as the temperature increases, rate of reaction will also increase. If the temperature decreases, rate of reaction will also decrease. Then comes the catalyst. Catalyst means what? The substances in whose presence the rate of chemical reaction changes. It may increase or it may decrease. So without causing any chemical change to itself, it is known as catalyst. Okay, so catalyst may increase the rate of reaction or it may decrease the rate of reaction. Depends upon us which catalyst we want to use. Whether we want to use the positive catalyst to increase the rate of reaction, or we want the negative catalyst to decrease the rate of reaction. Then comes the corrosion. Now, what do you mean by the corrosion? Corrosion is a natural process, okay, that converts a refined metal into a more chemically stable form, such as oxide, hydroxide, or sulfide. So it is the gradual destruction of material by chemical or electrochemical reaction with their environment. So the ability of the electrochemical process is to break the compounds into the elements or to create a new compound. It can be destructive as well as productive also. So corrosion is an all too common result of electrochemical reaction between the materials and the substances in the environment. Okay, so here we can say that corrosion is very dangerous. Okay, so here in this case, you might be seen like this example. Okay, many of the pipes, okay, oil pipes, then bridges, okay, then buildings, they get corroded. Now why they get corroded? Okay, because of the reaction, because of the reaction which are reaction happens between that particular chemical which is present over it and the chemicals which are present around the atmosphere. So it is a natural process which converts a refined metal into a more chemically stable form such as oxide, hydroxide, or sulfide. Okay, so this is one of the natural process which is acting naturally in the environment. So we can also call it as an electrochemical process, okay, which breaks down the compound in to create a new compound, or it can be destructive also, or it can be a productive also. Then corrosion is a dangerous and extremely costly problem, because if damage appears, then obviously we have to repair it. We have to give lots of money. So it is a highly cost, means it is costly problem, corrosion. So because of it, buildings, bridges, they can collapse. If corrosion appears, they can collapse. So then oil pipelines, then chemical plants, they leaks, then in the bathroom it may flood because of it. Then corroded electrical contacts can cause fires and other problems. So corroded medical implants may lead to blood poisoning, and air pollution has caused corrosion damage to works of arts around the world. Okay, this problem of corrosion is everywhere in the world, so it causes many of the damage. Then corrosion threatens the safe disposal of radioactive waste that must be stored in containers for tens of thousands of years. Okay, it threatens the safe disposal of radioactive waste. That means because of the corrosion, because of the fear of corrosion, we are unable to dispose that radioactive waste. Okay, and that's why for the thousands of years we have to store in a container, because if it corrodes, then it may give a massive it can give a massive explosion. So that's why we have to store it in a container, all the radioactive waste. Why? Because of the threat of the corrosion. So then comes how to protect the metals from the corrosion. Metals can be protected by electroplating with an inert or passivating metals. Now, inert means what? The element or the compound which will not react. Okay. Corrosion means what? Whatever the chemicals are present over that particular um, metal or element, then whatever the elements are present, whatever the chemicals are present, they start reacting with the atmosphere. An atmosphere contains number of gases. It may have pollutants. Okay, and whatever materials are there with that, it starts reacting, and because of which it can cause hazardous and destructive problems. So here in this case, to protect the metal from it, we are just electroplating it with an inert or passivating metal, so that what will happen, because of this it will not corrode easily. Okay, if that electroplating is removed, then in that case it can start corroding. But if you are just electroplating it with an inert or passivating metal, then what will happen, it will not corrode easily. So non-metallic coatings like that of plastics, paints and oils can also prevent the corrosion. That's why you might have seen that whatever that rod materials, iron materials, whatever that pipelines are there, okay, then different types of things are there. They are painted. Okay, they are painted with oils, then plastics, paints, then whatever the paints are there, with them we have to paint it by, so that this kind of corrosion will not happen. So this is one of the picture of corrosion. Okay, so I hope you have understood the topic which is taught today. So let's evaluate. What will happen if the reactant is in powdered form? Whether the rate of reaction will increase or the rate of reaction will decrease if the reaction is in powdered form. Yes, Anjali, unmute yourself. Anjali, Anjali, unmute. Give me the answer.
Yes, ma'am.
Yes, give me the
The
answer.
rate of reaction will decrease.
For what? Powdered form?
Ma'am, if it is in powder form, the rate of reaction will increase, and if it is not in powder form, it will decrease.
Yes, very good. Because as the if the size of the reactant will be low, then the rate of reaction will also be, it will be higher. Okay, because the surface area will increase and higher will be the rate of collision, and because of it rate of reaction will be higher. Now tell me what will happen if the reactant is in dilute form. That means it will, if it is not in concentrated form, if it is in dilute form, that means the number of molecules, if it is less in the reactant, then what will happen? Whether the rate of reaction will increase or decrease?
Ma'am, can I?
Yes, still.
Ma'am, the rate of reaction will decrease if it is in dilute form.
Yes, very good. The rate of reaction will decrease in dilute form because the concentration or the rate or the number of molecules are less in the dilute form. Now tell me what will happen if the temperature of the reaction increases? Yes, Mahima. Unmute yourself, Mahima.
Miss,
Yes.
rate of reaction will increase.
What will happen if the temperature of the reaction increases? Rate of reaction will increase or decrease if the temperature increases?
And rate of reaction is increase.
Increase. Yes, very good. As the temperature increases, the rate of reaction will also increase. Why? Because whatever the bonds are present between the compounds, it will break easily and the reaction will occur. So collision will also occur faster, and because of that, we will get the product fast. Then tell me the definition of catalyst, or what do you mean by the catalyst? Yes, Khushibano,
Yes, ma'am.
unmute your.
The substance in whose presence the rate of chemical reaction change without causing any chemical change to it is called a catalyst.
Yes, very good. So the substances in whose presence the rate of a chemical reaction changes. It may increase or it may decrease. So without causing any chemical change to itself. So it is known as the catalyst. So I hope you have understood with the topic. So the last part of the topic we will see in the next lecture. So I thank all the teachers and my dear students and BMC Education Department, and thank you all.